Okay, so here's what's happening. I told you that alkenes undergo addition reactions. So what happens in addition reactions is you got double bonds, things get added to the double bonds, electrophiles get added to these double bonds. And you've got bromination reaction, so usme bromine gets added to the double bond. Test for bromination, and I told you that it's there's a mechanism, and that's called electrophilic addition. Okay, what happens is that the double bond electrons, they repel the bromine molecule, and it gets polarized. The positive bromine gets attracted to it. It grabs all those electrons in the double bond and bonds with it. The carbon over here becomes a carbocation intermediate, and the Br minus one that I had left earlier, that then comes in, gets attracted to it, and bonds with it. So this was the mechanism of electrophilic addition. Clear here?
Yes.
Yes.
And every time it's going to be kind of the same mechanism. So the second reaction is going to be, and again, this is electrophilic addition. That second reaction is hydration of alkenes. So this is hydration of alkenes. What's going to happen in this reaction is, okay, you're going to have an alkene, and you will have a water molecule. Steam के साथ reaction होता है actually. इसको सही कर ले. So it's an alkene, and that alkene is going to go and it's going to react with. I said it's going to react with. There's going to be a double bond. I said there's a double bond in between, and it will react with water. Okay, so water के साथ reaction है water. So this is again an O-levels reaction. You did this in O-levels. They're going to react, and they will react under certain conditions. The conditions are 300 degrees centigrade temperature. There's going to be a 60 atmosphere pressure, and you're going to have acid catalyst. Specifically, phosphoric acid is frequently used as catalyst. And the product of this reaction will be that so there's going to be the alkene, and that alkene will that particular alkene will react with it. The double bond will go away, and you'll have two things attached to it. There's going to be an H, and there's going to be an OH that's going to get attached to it. Okay, so that's your reaction. That's your hydration reaction. Or there could be another product in this reaction, and that other product is this other product is it's going to get attached to the same thing. So you'll have a CH3. It's going to have this double bond, and the H and OH are going to get attached to it, except for one difference, and that difference is the OH now gets attached to the carbon that's on the left, and the H gets attached to the carbon that's on the right. Okay, so in either case, you're going to have an alcohol, but there'll be two alcohols. Okay, one of them is this one is propan-2-ol, and the other one, I said the other one is propan-1-ol. Okay, so you got two alcohols, propan-1-ol, propan-2-ol. I said there's a rule to it. There's one of them that's more likely to be produced. Like the idea clear is that there'll be two different alcohols being produced. Is that clear?
Yes, sir.
Yes.
और इसमें एक और चीज है कि this is a problem that is specifically in unsymmetric alkenes. I told you unsymmetric alkenes are where the double bond, the molecule looks different on both sides. Okay, so that's an unsymmetric molecule. So you're going to get two different products. So now one of them is a major product and the other one is a minor product. The first one that I drew, that's my minor product. And the second one that I drew, that's my major product. Okay, so you've got minor and major products. I said the rule for identifying minor and major products, that's known as the Markovnikov's rule. मतलब नाम भी important नहीं है. It's known as the Markovnikov's rule. ठीक है, that determines which one is the major and which one is the minor. Major का मतलब it's like if you have 10 products, 9 of them will be the major product, one of them will be, I mean, ये probability होगी. The major is more likely to be formed. So what's the Markovnikov's rule? It's a rule which states that the H likes to be bonded to the carbon. So it likes to be bonded to carbon in C double bond O, to carbon in C double bond C, which is already bonded to more hydrogen atoms. So which is already bonded to more H atoms. But according to this rule, if I have this molecule, I've got a double bond and I've got a carbon with CHs, and over here I've got a carbon with 3Hs, and this side I've got a carbon with H, carbon with H. So यहाँ पे ना I've got two carbons. अच्छा, I've got two carbons. One of them is bonded to two H atoms, right? The other atom is bonded to zero H atoms. X डाल देते हैं बीच में एक सेकेंड. अच्छा, the other one is bonded to zero hydrogen atoms, while this one is bonded to two hydrogen atoms. But the idea clear है, you've got two carbons. ठीक है, one of them is this one, the other one is this one. And वो साथ वाले carbon के H नहीं देखने, ठीक है? You have to look at the H atoms that are directly bonded to it. So one of them has more H's, the other one has fewer H's. Now, if I react it with water, so H and OH are going to get added to it, and according to the rule, the product that you're going to get is going to be the more likely product. Like if I had to draw just one, so the more likely product is going to be my major product. So it's going to be CH3 and C, and there's another CH3 on the top. So I've got a double bond, and I've got C, and I've got H, and I've got H. अच्छा, अब मुझे बताओ कि where will the H and where will the OH get bonded to? H के side पे bond होगा, OH के side पे bond होगा. And I'm talking about this double bond over here. क्या होगा? What's going to happen over here? इस point पे. मतलब rule के मुताबिक क्या होगा? Will the H like to be bonded to this carbon atom, or would it want to bond with the other carbon atom?
Or the other one, the left one.
यहाँ पे H से bond होना है.
जी सर.
क्यों?
सर क्योंकि ये दो कार्बन एटम के साथ अटैच्ड है जो बाकी हाइड्रोजन एटम के साथ अटैच्ड है. So more atoms are attached.
अच्छा, सॉरी, एक मैंने वो गलत लिख दिया, मैंने वो बीच में मिस ही कर दिया. हाँ, उस पॉइंट ऑफ व्यू से तो सही था. टू मोर H atoms. यहाँ पे हाइड्रोजन एटम्स की बात हो रही है, ठीक है? अब बताओ, who's bonded to more hydrogen atoms?
Fit right.
it's going to be the right one, okay? That's bonded to more H atoms. So the H will get bonded to this one and the OH will get bonded to this one. So that's your major product. Okay. Unaid, is this clear?
Clear, sir.
So that's the Markovnikov's rule. And that's my major. That's my major product. I'm going to have the minor product as well. That's the other way around. And so now the thing in this is, why is there a Markovnikov's rule? Like, what's wrong with the other product? Okay? Like, if I do a reaction, why do I get a minor product? And why is the other one more likely to be formed? So that's got a lot to do with the mechanism of this reaction. So I'm going to do the mechanism for this particular reaction. And this is also electrophilic addition. Okay? It's the same exact mechanism. Let me write it over here. So this is also. So this is also electrophilic addition. Now the thing is, so why do we have a Markovnikov's rule? That's the issue. Okay, so let me draw the mechanism first. The mechanism is when you have an unsymmetric alkene, so it's got a double bond, and there are H atoms on one side, and there is carbon branches on the other side. Now, the first step of this reaction mechanism is the first step is that the electrophile is going to get attracted to the double bond. Okay, so this is a case with Br2 molecule. Over here, water is going to be attracted. So you'll have water molecules coming in. So here's a water molecule. That water molecule has electrons, right? So when this molecule approaches the double bond has a lot of negative charge at this point. So the electrons in this water molecule are going to be repelled, right? The oxygen will become slight negative and the hydrogen over here will become slight positive, okay? Just like bromine. And when it becomes slight positive, it's going to get attracted to the double bond even more. Okay, that's the first step. Second step. The second step is that when this happens, so एक तो आपका जो molecule है, that's CH3, C double bond C, and it's got two H's. This one has a carbon chain. And just when this happens, so the water molecule has split up into two ions. One of them has become H+1 and the other one has become the OH-1. Because the electrons have repelled, okay? The bond has been broken heterolytically. You've got heterolytic bond fission. It's an unequal bond breaking. So abhi maine khali is pe focus kiya. The electrons over here, they end up with, these ones over here, they end up with OH and it becomes OH-1. The H over here loses electrons because the electrons are repelled by the double bond over here. Okay? Is that clear? Ye clear part?
Yes, sir.
Yes.
So now there's an issue. And that issue is, let's focus on this thing. Now that issue is when you reach this stage, now the H+1 is going to be attracted to the double bond electrons even more. So two things can happen. Either it's the H+1 is going to grab electrons and grab these electrons, and those electrons are going to drift away and they will end up with this H over here. And the H would lose its charge because it got its electrons, right? That charge would instead go to carbon now because carbon has actually lost electrons. So that's what will happen. The H+1 will go and will steal electrons. So is that clear?
Yes.
Is it clear? It ended up stealing electrons, right? And let's put the OH-1 over here, because in the next step, the OH minus 1 is going to come in with its electrons and it will get attracted to the other carbon atom, and that will complete the reaction mechanism. Okay, so what you're going to get is CH3, and there's a carbon, and then there's another CH3, and there's C and H. So pehle the first H came in, and then the OH came in on this side. Okay, that's the reaction mechanism. Achha, is this the major product or the minor product? कौन सा product है ये?
Major.
Okay, that's your major product, because the H over here has bonded to the carbon that's directly bonded to more H atoms. Achha, remember, directly bonded. This carbon atom is not bonded to any H atom, at least not directly. Okay, so Markovnikov's rule है कि it should be directly bonded to more H atoms. So it's going to get attached to the right one. Now there could have been another mechanism, which is where the H would have gotten bonded to एक बिल्कुल exact उसका same mechanism hota, except with one difference, and that difference would come at this point. Okay, the H is getting attracted to electrons right over here, but in the second mechanism, the only major difference would be वो ये वाला होता कि यहाँ वाला step हम दोबारा कर लेते हैं कि I had electrons in the double bond, right? So we had electrons in the double bond, and we had an H plus 1, and we had NaOH minus 1. Right? It was heterolytic bond fission. But now what happens is the H instead attracts electrons and bonds with the carbon that's on the left side. Now, और फिर से वही होगा कि the positive charge over here will appear on the carbon over there. ठीक है, because the H plus 1 took electrons from it. अच्छा, अब ये कि चलो वो हो गया. So the next part is you got OH minus 1, and the OH minus 1 is going to come in and it's going to bring its electrons, and it will bond with the carbocation that's over here. Okay, that is also done. So basically the H gets bonded to the carbon that's on the left, and the OH gets bonded to the carbon that's on the right. So you're getting two different mechanisms, which are kind of identical, but still two different. The first one is your major product. The next one is your, so this one is your major product. And this other one, that happens to be your minor product, less likely to be formed. So I've written down the mechanism, which is kind of exactly the same as bromination. Okay? Now there's this big question. Okay, why does the first one happen? Okay, the first one mainly happens because, और यहाँ पे मैं explain करता हूँ, ठीक है? You've got, नीचे में explain करो. अच्छा, you've got 3 types of carbocations. तो explanation ये है कि alkyl chains, sorry, not alkyl chains, carbocations that have more alkyl chains are more stable. And are more likely to be formed with more alkyl chains, which are electron donating. Electron, remember they're going to ask you for this. Okay, why is it are donating are more stable? So what does that actually mean? Carbocations with more alkyl chains, which are electron donating, are more stable and more likely to be formed. What that means is, here's a carbocation. It's got a positive charge. And on two sides, it's got H atoms. And on one side, you have a carbon chain. Okay, that's known as a 1-degree carbocation or a primary carbocation. अच्छा इसी तरह ना फिर there's another one which is you might have a carbon with positive charge and on two sides there could be a carbon chain. और एक side पे ना there is an H. So this one is a 2 degree. This one happens to be a 2 degree carbocation. और फिर आपके पास you've got a third one which is a 3 degree carbocation. ठीक है, you've got 1 degree, 2 degree, and finally a 3 degree carbocation. Same thing. Its only difference is, and it could be any size carbon chain. It's not necessary that it's CH3. You can have anything on the other sides. I mean, you could have a much bigger chain as well. Okay, that's a 3 degree carbocation. Now, a 3 degree carbocation is stable or is considered stable, and a 1 degree carbocation is considered unstable. So the question is why? And the answer to that particular query is कि why is a 3 degree carbocation stable? अच्छा ये तो पहले clear हो गया ना 1 degree, 2 degree, 3 degree carbocation. Is that clear?
जी सर.
हो रहा है clear है?
Yes.
इधर मुझे बताओ what carbocation is this one? 1 degree, 2 degree, 3 degree?
2 degree.
इसके ऊपर खड़े हो, how many carbon chains does it have?
सर 2 हैं.
Oh, is it 3, sir?
It's 3. It's
3 है. जी जी.
इधर भी CH3. It's got on all 3 sides you got car. अच्छा, what kind of a carbocation is this one? This one over here.
1 degree.
ठीक है, this is 1 degree because on 2 sides it's got 2 H's and only one side it's got a carbon atom, right? So तो मैंने इसके ऊपर लिख लेता हूँ. This one is a 3 degree carbocation. ठीक है, तो अभी तक आइडिया ये हुआ है कि 3 degree carbocation is more likely to be formed. It's more stable, and a 1 degree carbocation is kind of unstable, right? ठीक है. So अब फिर से क्वेश्चन ये कि why? ठीक है, why is it harder to form a 1 degree carbocation? Why is it a lot easier to form a 3 degree carbocation? And the answer to that is कि look at these 3 carbocations, right? You got a positive charge over here. अब difference जो है ना, these 3 positive charges, they're not exactly the same. One of them is small, the other ones are bigger in size. Or you can say they have a lower charge density. So this one is actually pretty large. ये वाला जो है ना, positive charge, that's kind of really large. और ये जो 3 degree carbocation का जो positive charge है ना, that's kind of really small. And I'll explain why. ठीक है, the reason is over here you've got a positive charge that's right in the center of a molecule, right? The top पे कितने electrons इसके? That's carbon has 6 electrons, hydrogen has 3 electrons, so there's basically 9 electrons around it. There's 9 electrons on this side. There's 9 electrons over here as well. और फिर ना यहाँ पे भी ना there are 9 electrons. So that positive charge is surrounded by how many? 27 electrons. मतलब बीच में ना, do you get the point? It's surrounded by 27 electrons. So imagine there's a positive charge and that is surrounded by 27 electrons. 9 top pair, 9 left pair, 9 bottom pair. What will happen is, to quite an extent, that positive charge is going to get neutralized because of the huge number of electrons that are surrounding it. Is that clear?
तो सर क्या हम कह सकते हैं ये शील्डिंग इफेक्ट है?
वो भी कह सकते हैं कि it's kind of getting shielded as well, लेकिन वो positive charge है ना, so it will try to attract the electron cloud. ठीक है, ये जो tops है ना, electrons, but it won't be able to gain those electrons because they're not letting go of those electrons. So to some extent, a tiny bit of negative charge will kind of come over here and neutralize the positive charge. These electrons, a tiny bit of negative charge will come and neutralize the positive charge. So the positive charge would kind of, या तो आप कह सकते हैं, kind of gets shielded, it is basically small in size. Is that clear?
जी sir.
Unaid, clear?
Yes, sir. Yes.
Achha, on the other hand, that one is pretty large because it's not getting neutralized from all sides. I mean, you got 9 electrons over here, but hydrogen just has 1 electron, and this hydrogen also has. So it's not surrounded by too many electrons, right? So इस statement का तो ये मतलब है कि carbocations with more alkyl chains which are electron donating. Remember, when you have a carbon chain, that is by nature electron donating. It has a lot of electrons. ठीक है? A hydrogen atom does not have a lot of electrons. तो अगर किसी चीज के साथ you have a carbon chain, there's a very small electron donating effect. A very small, ये नहीं कि it's going to give 9 electrons. But maybe the negative charge of, let's say, 0.5 electrons might slightly be closer to the carbon atom that's in the middle over here. अच्छा, तो एक बात clear है कि positive charge large and positive charge small. Is that clear?
जी sir.
Yes, sir.
अच्छा, फिर issue ये है कि why is having a large positive charge unstable? And the answer to that is, इनमें से किसके ऊपर ये 1 degree है ना? अच्छा, 1 degree carbocation. So having a large positive charge, I told you, is unstable. What will happen is it would be very hard to form a large positive charge. I mean, let's get that एक step पीछे चले जाते हैं, इसको पीछे करें. Why was there a positive charge in the first place? Because somebody came and took its electrons away, right? So these electrons were actually part of the double bond, right? So there was a hydrogen atom coming in which had a positive charge and it wanted to steal electrons from the double bond, right? यहाँ से start हुई ना कहानी. So the point is that these electrons are going to go, they're going to go towards the hydrogen. And hydrogen will no longer have a positive charge, but the positive charge will shift to the carbon atom over here because somebody stole its electrons. And if this positive charge is large, will it allow the hydrogen to steal electrons? कि नहीं. अगर तो ये positive charge large है, why would it give the electrons to hydrogen? It's going to pull those electrons back. Do you get my point?
जी sir.
But is this clear?
जी sir.
Hunaid,
Yes.
do you get this point?
Yes, yes.
The point is that a 1 degree carbocation form ही नहीं होगा. It's not going to get formed in the first place because whenever it gets formed, the positive charge is so large on this carbon atom that the electrons just come back. ठीक है? So remember, there's things that have a very large positive charge or a very large negative charge. They're difficult to form because I mean, they're going to do something. They would be very unstable. It would be very hard for them to actually exist because immediately they're going to try and grab electrons from somewhere. In this case, they're going to grab electrons from the one who's stealing those electrons. They won't allow that thing to steal the electrons in the first place. ठीक है? मतलब फॉर्म तो बाद में होगा, कोई उससे इलेक्ट्रॉन स्टील करेगा तो फॉर्म होगा ना वो, तो वो फॉर्म ही नहीं होगा. तो इज दैट पॉइंट क्लियर?
जी सर. तो इससे जो अगला स्टेप होगा वो होगा ही नहीं ना, यानी OH आयन
मतलब वो,
1 degree कार्बन
हाँ
कैटायन के
मतलब
साथ अटैच.
वो बना ही नहीं, वो H+1 वैसे के वैसे ही बैठा हुआ है. वो इट्स ट्राइंग टू स्टील इलेक्ट्रॉन्स, बट द कार्बन जो भी कार्बोकैटायन फॉर्म होता है that has a very large positive charge, right? So that thing never happens basically.
ओके सर.
लेकिन दूसरे केस में it happens. Why? Because when the H came and stole the electrons from this carbon atom and this carbon became a positive charge, the positive charge was not large because it could get electrons from elsewhere. There are 9 electrons. So it's surrounded by electrons, right? So this carbon will allow the H to take away electrons. So is that point clear?
जी सर.
Yes.
तो आपने याद ये रखना है कि a very large positive charge is very unstable, and it won't even form in the first place, because to form a very large positive charge you have to take away electrons from it. So if it's a very large positive charge, you wouldn't be able to take electrons away from it in the first place. So वो बनेगा किस तरह? It won't form. So that's the logic behind that, and either मैं large or small ना, I'm going to write charge density over here. This is or we can say high charge density, जो technical word है. You don't say large, you say high charge density. और इसमें you've got a low charge density. ठीक है, this one is a low charge density. तो अच्छा, तो आपने ना बस एक लाइन याद रखनी है, which is, I mean, you don't have to go into a lot into that much detail. The only thing you have to remember is, उसको मैं highlight कर लेता हूँ. अच्छा, so the only thing you have to remember is this thing, which is ये सारा. इसको एक सेकंड. बस ये, ठीक है. That's the only stuff that you have to remember out of all this thing. I mean, you have to understand that there's a 3 degree, 1 degree carbocation. You have to watch out for that. Like overall, you just have to, you got to remember this part. ठीक है, इस पूरी चीज पे. Major product, minor product, and that's the reason for that. Explanation के just one line. Carbocations that have more alkyl chains, which are electronegating, are more stable. बल्कि आगे भी लिख लेते हैं, as they have a lower charge density. So is that clear?
जी सर.
Yes.
As anyways, as they have a lower charge density. So that's it. Achha, then moving on. What are the reactions? It's kind of what's Markovnikov's rule? Remember Markovnikov's rule? Let's do other reactions. Other reactions number 3. There's a this reaction ki hydration reactions. It doesn't really have any major significance except for the fact that it adds OH groups. So there's another one which is hydrogenation. Okay, so there's a reaction called hydrogenation, and ये भी उसका है O levels का, ठीक है, IGCSE. So hydrogenation is कि you have an alkene and hydrogen gets added to it. अच्छा, इसकी significance क्या थी इस reaction की? I mean hydrogenation reaction.
Alkene to alkane करता था.
ठीक है, nickel or platinum catalyst 150 degrees centigrade was the temperature. अच्छा, it would turn it into an alkane. So what you'll get is H and H on both sides. ठीक है, so unsaturated became saturated. फायदा इसका क्या था unsaturated becoming saturated? That the size increases. So molecule size slightly, very slightly increases. I said it very slightly. Molecule size very slightly increases. What happens then? Van der Waals forces increase slightly. You have more intermolecular forces. And you have higher melting and boiling points. तो बताओ क्या इंडस्ट्रियल एप्लीकेशन थी इसकी?
Margarine production, sir.
ठीक है, margarine production was the main one. के अच्छा, what used to happen was कि margarine vegetable oil, unsaturated vegetable oil will turn into, you increase the melting point of vegetable oil. Vegetable oil is liquid. तो अच्छा, vegetable oil is, अगर कोई actual reaction आ जाए, हाँ ये जैसा, ठीक है, just wanted to show you. अच्छा, so this one. So I'm not really sure if this is, but this is how a typical molecule of fat looks like. ठीक है, oil वगैरह कहते हैं ना, this is how, so this is how the molecule actually kind of looks like. So so I think this is your typical unsaturated vegetable oil. And it's a big molecule, but it's got double bonds in it. That one, the other one, that's also a big molecule, but it's got fewer double bonds. Molecule का जो size है ना, that slightly increases. So your unsaturated vegetable oil, so that has turned into margarine. या उधर ना लिखा हुआ था घी लिखा हुआ था, ठीक है, it's got higher, so margarine basically has higher melting and boiling points, and अब उसका कोई फायदा तो खास नहीं है, it's just a substitute for butter, like you can put it on bread, it can solidify, so I don't think इसके अलावा कोई खास फायदा है, तो it's like an alternate for butter, ठीक है, because sometimes you don't want the oil to be actually liquid. So is this clear?
जी सर.
तो बस इसका और कोई फायदा नहीं, अच्छा इसका बस यही है. चलो ठीक है, फिर ये कल कंटिन्यू करते हैं. इसका एक वो मैं ऐड कर देता हूँ. दिस इज एन एग्जांपल ऑफ, it's not exactly electrophilic addition. It's kind of similar, but I mean the reaction is kind of similar. It's almost the same. But this one is an example of heterogeneous catalyst. ठीक है, it's an example of heterogeneous catalyst. उसके अंदर होता ही है कि heterogeneous catalysis के अंदर quickly अगर मैं बताऊं ना, there are two steps, like what's the reaction mechanism for this. You've got a nickel catalyst, so let's assume that this is the surface of nickel or platinum, and there's a molecule of an alkene coming in, trying to bond with H2. But the reaction has high activation energy. Why? Because the double bond, it's kind of hard to break. So what's going to happen is कि जो transition metals होते हैं ना, they have this tendency to actually attract electrons. very slightly, not very strongly. Transition metals, yeah, they're very unreactive. I mean, they don't like to lose electrons. Gold does not like to form ions. It doesn't like to lose electrons. Instead, it actually likes to kind of attract electrons, but not very strongly. The idea clear is that group 1 likes to lose electrons a lot. Transition metals, they don't really like to lose electrons. Instead, they have this very, very weak attraction for electrons. Is this point clear?
जी सर.
तो आपकी आयरन की चेयर क्यों नहीं रिएक्ट करती? Because it doesn't. Iron doesn't like to lose electrons. Gold does not react, doesn't like to lose electrons. Instead, they very slightly like to attract electrons. So what they'll do is, wo jo pi electron cloud hai na, that will get attracted to, very slightly get attracted to the nickel. And the same happens to H. The electrons in the H atom that will get attracted to, that will kind of get attracted to H. As a result, their old bonds are going to break. And now what can happen is new bonds can be formed. So आपका जो molecules है ना, they'll stick to the surface of the catalyst, and as a result, the double bond breaks, and very weak attraction is existing between. यहाँ पे ना, there's very weak attraction between nickel and इनके बीच में. These weak bonds are also going to break eventually. ठीक है, all these weak bonds are eventually going to break, and the molecule is going to fly off. This H will also fly off. ठीक है, they're all going to go their separate ways. And when they actually go their separate ways, their old bonds have been broken now. Now what can happen is your new bonds can actually form. So now there's this possibility that new bonds can easily form. I mean, this H can go and bond with this. This H can also go and bond with this. So is this idea clear? Okay, this is how a heterogeneous catalyst works. Is that clear?
जी सर.
और इसका मैं वो लिख भी definition लिख लेता हूँ. The first step is adsorption. ठीक है, there's a thing called adsorption. In adsorption, catalysts and reactants, they form weak bonds, very weak bonds.
Sir, is that a D or a B?
It's a D.
A D. Oh.
ये मतलब science वाला adsorption, it's not absorption. ठीक है. I mean, this is the. So they form very weak bonds. And the next step is deadsorption. Those weak bonds, they break. And now new bonds can be formed. तो बस ये खत्म करते हैं catalyst. बल्कि weak bonds between catalyst or the weak bonds above the break. Between catalyst, कहाँ पे चला गया? ऐसे ही deadsorption. Between catalysts and reactants, they break. Now, new bonds can form. ठीक है, सही है, clear है ये? Last part.
जी सर.
Heterogeneous catalyst, ठीक है? तो इसका mechanism that's different. I mean, it's also counted as electrophilic addition, except I mean the whole thing works differently because you've got a catalyst, ठीक है? चलो ठीक है, ये फिर करते हैं कल.
ओके सर.
चलो, ओके.
खुदा हाफिज़.
Take care.
Thank you, sir.